Hello everybody, today we're going to do a review of composition of functions and inverse functions. First we're going to tackle the composition of functions, and remember you are going to see notation like this. This is how I would read this part here. F of g of x. Two different notations, you can see it this way or this way. They both mean the same thing. What we need to remember when we're doing this is if I am taking f of g of x, then I am taking my g of x function and I am substituting it in for x in my f function. So take my g of x, put it in for x in my f of x function. So let's take a look at this example where f of x is equal to x plus 1, g of x is equal to 2x. If I'm taking f of g of x, I'm going to take my g of x, and anywhere there is an x in my f function, so I'm just going to circle there's only the one here, I will substitute in 2x instead of the x. So I first take my 2 of x, replace it into where x is in the f function, and I will get 2x plus 1. Let's then go ahead and look at an example. On the next page here we have f of x equals 5x, g of x equals x squared plus 1. We want to find f of g of x. So I'm going to take my g of x function, put it in wherever there's an x in my f function. So this is part A. I'm going to take my g of x and replace the x in the f of x function. If I write my f of x function, I have 5 times x, and nowhere else is there an x. So right away I'm going to put some parentheses down so I can fill it in with my g of x function. That would be x squared plus 1. And if I simplify that, then I will get 5x squared plus 5, and that is equal to f of g of x. Part B wants me to find g of f of x. So for part B, I'm going to take the f function, and anywhere there's an x in my g function, I'm going to replace it with the f of x function. So if I start to write down my g of x function, I have x squared, so I'm going to give myself parentheses for the x, because I'm going to replace it with something else. Then I'm going to square it and add 1. If I fill in now my substitution, which is f of x, I'm going to put in 5x. Now I'm going to simplify this, and remember, if I have 5x in parentheses, every piece of that is being squared, so I will get 25x squared, and then I have my plus 1 at the end. So g of f of x is equal to 25x squared plus 1. Alright, let's take a look then. What happens if we are finding f of g of negative 2? And we're using the same functions as above. Now, two ways I can solve this. And then after that, I'm going to come back and bring your attention to this little note here. But let's first solve f of g of negative 2. I've got two methods to do this. If I already have f of g of x, then I can just substitute in for my x this negative 2 value. So I can substitute negative 2 in for x, and this f of g of x we solved in part A above. So this is the same as part A above. That function, f of g of x, we found to be equal to 5x squared plus 5. So I just need to put my negative 2 in for x in this function. So I would have 5 times negative 2 squared plus 5, or 5 times 4 plus 5, giving me 25. My second method for doing this, so this is an or, 1 or 2. My second method to find f of g of negative 2 would be to first find g of negative 2. If I do that, I'm going to put a negative 2 into x for my g function. So remember, g was equal to x squared plus 1. So I'm going to put in a negative 2, square it, and add 1. And if I solve that, I get 4 plus 1, or 5. Now to get my f function for that, I'm going to take this 5 and put it in for x. So I'm going to find f of 5. My f function was equal to 5 times x, so that's going to be equal to 5 times 5, which is 25. So either method works. I can either use method 2 or method 1. I get the same answer for both. And I want to bring you back up to this note over here. In this example 1, when we found f of g of x and g of f of x, we found these, and I'm going to fill in right above. G of f of x was equal to 25x squared plus 1. F of g of x, if you remember from part A above here, is equal to 5x squared plus 5. Not the same. So what this tells us is they do not always give us the same answer, so this is not a commutative property. In other words, commutative properties where we can change the order of something and have our results be the same. We cannot change the order for composition of functions. Okay? We don't necessarily get the same thing, so not a commutative property. Let's now go to our next example here. We want to find, first of all, h of p of 3 this time. So I'm finding h of p of 3. Since I don't have a function for h of p of x, I'm going to go ahead and first find p of 3. When I find that, I'm going to put that in to my h function. So p of 3, if I put in 3 for x, I'm going to have, using my x plus 2 function, 3 for x plus my 2 gives me 5. Then I want to take that 5 and I want to put it in my h function and find h of 5. H of x is just x squared, so I'm going to replace my x with 5, square that, and I get 25. This was using method 2 from the previous example. Part B now wants me to find h of p of x. So I'm going to put my p of x function into the x value for my h function. So my h function says I have x squared. I'm substituting something in for x, and that something is my p of x, which is x plus 2. So this is a binomial squared, should give me a trinomial, 3 terms I should end up with. You can use the box method to multiply that out. If you do, you get x squared plus 4x plus 4. And that is h of p of x. Alright, that brings us now to inverse functions, which are related to composition of functions. I think the best thing for us right now would be to start doing some practice problems, but you should be aware of what an inverse function is, so I expect that you will read this information on your own. And if I go to the next page, there is more information that, again, I would like you to read. we are going to come down and look at our definition down here. Definition of one-to-one function. Just so you know, this was not going to be covered on the midterm, but it will be on the final exam, so you still will need to know for our final exam, and we will review this more in class before the final. So what we're going to do now is head on over to our next page and look at how do we find the inverse of a function. Several different ways we could do this. If we're given ordered pairs, like coordinate pairs, we would just swap our x and y values. So whatever was in x, we would switch into our y values. Whatever is in our y values, we would switch into our x values. So if you are given a function and it's defined by coordinate pairs, to get the inverse, you would just take each of those and reverse them. So down here, inverse of that is 4, 3, negative 2, 1, etc. Most likely, though, what you will find in our class is finding the inverse algebraically. So we have our 3 steps. First one being set your function equal to y, or in other words, replace that function notation with y. Then second, we swap our x and y values, solve for y, so we isolate the y value, and rewrite in our function notation, so you would replace your y with the inverse function notation, and let that equal whatever it is you get for y. So let's look at some examples now. First one, just a linear equation, f of x is equal to x minus 4. First step is replace that f of x with y, so I'm going to write y equals x minus 4. Second step, swap your x and y's, so I'm going to put in x equals y minus 4. Next, third step, I want to solve for y, or get it by itself. This one pretty straightforward. Add 4 to both sides. X plus 4 equals y. And then I'm just going to write this in my inverse function notation. So I'm replacing y with f inverse of x, and that's equal to x plus 4. Next example, a little bit trickier, but not too much. First step, I'm going to replace my f of x with y. Second step, switch my x and y values. And then I have to isolate my y, get y by itself. I've got it in both the numerator and a denominator of fraction, so I think what I'm going to do here is cross multiply. So I will get, getting y by itself here, x times y equals 1 times y plus 1. I need to get all my y terms together on one side of the equation, so I'm going to subtract y from both sides, and I will have xy minus y equals 1. Factor out the y, and I get y times x minus 1. And then finally, divide both sides by x minus 1. Y equals 1 over x minus 1. Replace my y with the inverse function notation. And there I have the inverse. All right, so last thing we need to make sure we understand is what these inverse looks like if we graph them. So if we graph an inverse relation, we take our original graph and we reflect it over the identity line. That's the line with the equation y equals x. So in this example here, in this blue, we have our function f of x equals 2x plus 3. I'm just going to label this one f of x. And in the green here is our y equals x line. That's our reflection line for inverse functions. If I reflect it, I'm going to get this red dotted line here, and if I look to write the equation of that, it's a linear equation that I need, and I can write it in y equals mx plus b form. My b, or y-intercept, looks like negative 1.5, so mx plus b, something x minus 1.5. And I need my slope. Looks like I go up a half a unit over 1, so my slope would be half, or 0.5. So there's the equation for the inverse. I'm going to rewrite this one and call it inverse function of x. Looks like 0.5x minus 1.5. The reason I did that is because down here in this note, I want you to understand if I take the composition of a function and its inverse, in other words, f of the inverse function of x, I would take my inverse function, substitute it in for x in my f of x. So remember, f of x was equal to 2x plus 3. Write that down here. And we found our inverse from the graph to be 0.5x minus 1.5. So if I use what I know about compositions of functions to find f of the inverse function of x, I would have, taking my inverse function and substituting into f of x, 2 times whatever I'm substituting in for x, plus 3. I'm substituting in my inverse function. That would be 0.5x minus 1.5, which gives me, when I distribute here, 2 times 0.5 is 1. 2 times a negative 1.5 would be 3. And then I bring down my plus 3, which equals, these will cancel, and I have x. This essentially gives me that y equals x line, which is my identity line. So if I take f of the inverse function of x, I get this identity line y equals x. Alright, that's it for this review. You have some problems that you can try and catch up on for review, and I will see you tomorrow in class.